Hi again. Welcome to the third of the three videos on financial loans analysed with geometric series. Previously we have examined basic techniques in the analysis as well as how to adapt to changes such as missing payments or interest-free deals. In this video we use the same approach but examine changes to basic conditions of loans, especially changing interest rates and making special contributions. So we start with changing the interest rate. For example, a loan of $400,000 is taken out at an interest rate of 6% per annum, compounded monthly over 25 years. Monthly repayment is M dollars, amount owing after N months is AN dollars. First of all, we've got to show the amount of each repayment is $2,500. I'm not going to go into this in detail because we've done it many times. So after month 1, A1 is 400,000 times the interest rate minus the repayment. After month 2, same deal. What was at the end of month 1 times the interest rate minus the repayment, and we can expand that to make it look easier to handle. After month 3, same deal, and we can factorise out in the second line the M term, and so we're left with a little geometric series. So after month 300, which is 25 times 12, we've got $400,000 times 1.005, the interest rate, to the 300th, minus M, and then the sum of N terms, which is 1 minus 1.005 to the 300 over 1 minus 005. So put that in your calculator and you get M is equal to $2,577.21. So the second part of the question is that after 5 years the interest rate rises to 9%. Find the new monthly repayment amount given the term of the loan is still 25 years. Well, we've just calculated the expected monthly repayment figure for the whole lot, and the amount of still owing at the end of 5 years using that figure is A60, because it's 60 months, equals 400,000, the amount borrowed, times the interest rate to the 60 months, minus the repayment rate we calculated, times the sum of 60 terms of the geometric series. We calculate that to be $359,728.04, which is the amount still owing. So we have to go now for another 240 months. So we just use the same formula but replace the 400,000 with the new amount we've just calculated, and the interest rates going from 0.005 to 0.075. And so we just put that into our normal calculator because the equation equals 0, and we find that the monthly repayment is $3,236.57, which is significantly higher than it used to be. Now we look at the situation where we want to make an additional contribution. For example, Holly wants to borrow $10,000. The bank agrees to a 6% interest rate compounding monthly with payments at the end of each month. Holly's informed that there'll be no penalty if she pays the loan off before the end of 12 months. So we have to find out first what the normal situation is, how much is she going to pay. So end of month 12, we can write this straight down. The balance is going to be 0 because she's going to have repaid it. She's got her loan, $10,000, the interest rate, 1.005 to the 12 months, minus the repayment and the sum of 12 terms of the geometric series. Put it in your calculator. Holly has to pay $860.66 per month. Now after the sixth payment, Holly owes $5,074.83, and you can check that. At that time, she receives a bonus from her employer of $2,300 because Holly's a very, very good worker. So she thinks, what'll I do with it? I'll put it immediately towards my loan. Very sound thinking, Holly. When will Holly now complete her loan while making her same repayments? Because she's used to them, so may as well continue. Well, writing it straight down, the balance after 12 months is going to be 0. Her balance is going to be $2,774.83, which is the $5,000 minus the $2,300. That amount is going to be multiplied by the interest rate to the end months minus the repayment rate, which we just calculated, times the sum of n terms of the geometric series. So we put the bit that I've circled into the calculator, as we always do, because we want to get rid of that denominator so we can get to the 1.005 to the n terms, and we get this massive figure of 172,132. It's still a lovely number, just a bit bigger than we'd expected, but that doesn't matter. So we expand the brackets and we then collect our like terms, and we have 172,132 minus 169,357 times 1.005 to the n. Dividing, you get, and you can simplify it if you wanted to, 1.0164 for the division. Take your logs of both sides and change the base at the same time. So you have log of 1.0164 divided by the log of the 1.005, gives you 3.26. So Holly finishes her loan after 3 and a bit more months. So that's in the 10th month. And her last repayment is going to be the 0.26 times her normal repayment, which is $222. So she's done pretty well. Well done. So people, that summarises the main loan problems. Certainly there are other variations, but they will follow from what we have discussed in these 3 videos. Consolidate what you've learned here by doing the Loans Test Yourself questions, and there's more than one, on the website drjoesmaths.com. Hit the like button and subscribe if you haven't already, then you get notifications about new videos. Good luck. See you on another topic. Check the playlist.